Hey, welcome to Linear Equations. This is for intermediate algebra. My name is Tuesday J. Johnson. I'm an assistant professor at Doña Ana Community College and a lecturer at the University of Texas, El Paso. Intermediate Algebra is a Math 120 course. We're using the textbook Turner and McKeague Intermediate Algebra, Chapter 2, Equations and Inequalities in One Variable. And this is particularly Section 2.1 on linear equations. So let's start with some definitions. A linear equation in one variable is any equation that can be put in the form ax plus b equals 0. So can be. It might look different along the way, but you could manipulate it in such a way that it looked like ax plus b equals 0. A and b are constants, x is our variable, and we cannot have an a value of 0 or else we have no variable. The solution set for an equation of this type is the set of all numbers that, when used in place of the variable, make the equation a true statement. Two or more equations with the same solution set are called equivalent equations. All right, so when we manipulate our equations, we'll want to always get equivalent equations. How do we manipulate those equations? We're going to first use the addition property of equality. So for any three algebraic expressions, a, b, and c, if a is equal to b, then adding c on both sides keeps the equality the same. In other words, adding the same quantity to both sides of an equation will not change the solution set. Remember that adding a negative is the same as subtraction, so this holds for both addition and subtraction. We also have a multiplication property of equality. And for any three algebraic expressions, a, b, and c, as long as c is not equal to 0, if a is equal to b, then we can multiply both sides of the equation by c, and we still have equality. In other words, multiplying both sides of an equation by the same non-zero quantity will not change the solution set. Remember that multiplying by a fraction is the same as the operation of division. So if I multiplied both sides by a third, I could think of that as dividing both sides by 3. So the multiplication property is also a division property of equality. Example 1. So we're going to solve 5 minus 2x equals 3x plus 1. And we're going to do this step by step at first. The first thing I'm going to do is I'm going to subtract 5 from both sides, always separated by the equal sign in the middle. And maybe you would even want to draw a line here so you can see sides of the equation as you're going through it. That way you make sure you always cross the equal sign when you're subtracting, right? When I'm adding the opposite of 5. Adding the opposite, I'm subtracting 5 on both sides. On the left, I still have a minus 2x. On the right, I have a 3x, and positive 1 combined with negative 5 gives me a negative 4. In my second step, I'm going to move all my x's to the left-hand side, so I'm going to subtract 3x from the right, and I'm going to subtract 3x from the left. The reason I do this is so that my x's will cancel out. 3x minus 3x canceled out, just like my 5 and my minus 5 canceled out. Negative 2x minus 3x will give us a negative 5x on the left. We still have our negative 4 on the right-hand side. To get x by itself using the multiplication principle, I can divide both sides by a negative 5. Negative 4 divided by a negative 5 is a positive 4/5. So in the first two steps, we use the addition property, even though we were subtracting. And in the last step, we used the multiplication property of equality to get the variable by itself. Example 2. If we're solving 1/2 x plus 1/4 equals 1/3 x plus 5/4, the first thing I'm going to do anytime I have an equation that has denominators, I'm going to find the least common denominator. With the denominators of 2, 3, and 4, we can write out all of our multiples of 4. So it's 4. And then I ask myself, does 2 go into 4? Yes. Does 3 go into 4? No, it doesn't, so I can't use that. Next multiple of 4, that's an 8. Does 2 go into 8? Yes. Does 3 go into 8? No, so that's not a common multiple. The next multiple of 4 is 12. 2 goes into 12, 3 goes into 12, and 4 goes into 12, and that's how I find my common denominator. So what I'm going to do with that common denominator is I'm going to multiply every single term of our original equation by 12. So 12 times a half of x, 12 times 1/4, equal sign, 12 times 1/3 x, plus 12 times 5/4. And when I do this, let's bring back our little pen here. We know that 2 goes into 12 6 times. 6 times 1 is 6 with the x, and I'll end up with 6x. I know that 12 times 1/4, right? 4 goes into 12 3 times, so I'll have a plus 3 on the left-hand side. On the right side of our equation, 3 goes into 12 4 times. 4 times 1x is 4x. 4 goes into 12 3 times. 3 times 5 will give us our 15. So by multiplying by the least common denominator, I've multiplied by something that will cancel every single denominator. And now I have an equation that looks a lot like our first example. I'm going to subtract 3 from both sides. I'll end up with 6x equals 4x plus 12. I'm going to subtract 4x from both sides, and I didn't type it out for you, but if you need it written in, we're going to subtract 4x. Yep, it's hard writing that tiny spot right there. Minus 4x. And that's how I get 2x. Right? 6x minus 4x is 2x. I swear to you that says a minus 4x and it cancels out. Equals 12 on the right hand side. Divide both sides by 2. X equals 6. We should check our answer up top. Half of 6 is 3. 3 plus 1/4 is 3.25. On the right side, 1/3 of 6, right, our answer, 1/3 of 6 is 2. 2 plus 1 1/4 is 3 1/4, 3.25, same answer left and right. If we're solving, negative 0.3y plus 0.1 equals 0.5. It doesn't look like we have fractions, but decimals are a way of writing fractions, fractions with a denominator that are powers of 10. In this case, since everything has a single decimal place, we're going to multiply every single term in the equation by 10. 10, we'll move the decimal 1 spot. 10 times a negative 0.3y is a negative 3y. 10 times 0.1 is 1. 10 times 0.5 is 5. To solve, I'm going to subtract both sides, subtract 1 from both sides. Negative 3y equals 4. In order to get y by itself, I'm going to divide by the negative 3. You could leave the negative in the denominator if you want to. It's common to move that negative out in front. Negative 4/3 would be our answer. Alright, so we did some solving. Here's some how-to steps just to keep everything straight as you're doing your own examples. So we're going to use the distributive property with grouping symbols to separate terms if necessary. So if fractions are present, we're going to multiply both sides by the LCD to eliminate fractions. Remember, that's least common denominator. If decimals are present, consider multiplying both sides by a power of 10 to clear the equations of decimals. We're going to combine similar terms on each side of the equation. So if you have a couple of x's on the left and maybe some numbers on the right, we're going to combine those together before we start switching sides. Step 2. We'll use the addition property of equality to get all variable terms on one side of the equation and all constant terms on the other side. Then we're going to use the multiplication property to get the variable by itself on one side of the equation. Check your solution in the original equation to be sure that you've not made an error. Now, one thing I like to do is use the order of operations. Order of operations, P, E, multiply and divide. Add and subtract, PEMDAS. We're used to going order of operations top down, and that's for simplifying. But when we're solving equations, we're peeling away. And when we solve, we actually start at the bottom and go up. Notice we use the addition property first. Use the addition property of equality. And then use the multiplication property of equality. And so the order of operations gives us good information for simplifying. It gives us some good information for rules with exponents, but it also helps us to peel apart in solving an equation. More examples. Example 4. We're going to solve 6 times y minus 3 minus 5 times y plus 2 equals 8. So we're going to get rid of our grouping symbols. We're going to multiply 6 times y, 6y. 6 times a negative 3 is negative 18. Minus 5y and a minus 10 equals 8. Now we're going to combine all of our like terms on the left side. We're not going to cross our equal sign until we have the left side as tight as it can be. So 6y and a negative 5y gives me a 1y. Negative 18 and negative 10 gives me a negative 28. These are all on the left side. So I'm not changing the signs. I'm just combining like terms on the left. The 8 is all alone on the right-hand side. Now that I have y minus 28 equals 8, we can add 28 to both sides and get our answer, y equals 36. Example 5, 7x plus 9 equals 3, parentheses, 2x minus 1, close parentheses, plus x. First, we distribute. On the left, 7x plus 9. On the right, 6x minus 3 plus x. Combine our like terms here on the right, the left side. We have one term that has x's, one term that is constant. On the right, we have two variable terms, so 6x and x gives us 7x. Still have our negative 3. And some of you might see something funky going on at this point. If you don't notice it, that's all right. I'll come back and explain to you what it is that you see. Let's just keep going. Let's take all of the constant terms to the right. So I'm going to subtract 9 from both sides. When I subtract 9, cancels on the left. Negative 3 and negative 9 will give me a negative 12 on the right. When I subtract 7x from the right, so that I move all of my constants to the left, check out what happens. Well, 7x on the left minus 7x, they cancel out and gives me 0. When is 0 equal to negative 12? Well, if it's your checkbook, you have $0 and you have negative $12, you would think that it's pretty much the same. You don't have any money. But $0 will not get you a fee, whereas negative $12 in your checking account generally gets you a fee. We call this a contradiction. That can never be possible. 0 is never equal to negative 12, and so there is no solution for this particular type of example. Example 6, our last example. 6 times 4 minus 3x equals 2 times 12 minus 9x. First we distribute. 6 times 4 is 24. 6 times a negative 3x is a negative 18x. 2 times 12 is 24, and 2 times a negative 9x is a negative 18x. In this case, the 24 minus 24, when I subtract from both sides, they cancel out. Negative 18x equals negative 18x. When I add 18x to both sides, I get 0 equals 0. This is what's called an identity. Any x that you choose will always work in this equation. So the solution set consists of all real numbers. The equation's always true. And I forgot to mention in the last slide, but here I see that I have 24 on each side. I have a negative 18x on each side. The left side looks exactly like the right side. Whereas in our last example, it looked more like this. We had 7x plus 9 equals 7x minus 3. When I subtracted 9 from both sides, I ended up with 7x equals 7x minus 12. But at this stage, we can see, hey, look, they both have a 7x. That looks in common. So they're balanced with that, but the number portions are not balanced. And since 9 is not the same as negative 3, this might be where you had that inkling of, hey, something's wrong. And that's where we got the contradiction. Whereas in this example 6, we end up with 0 equals 0. Everything looks great. And that's why it's an identity.